Okay, morning everyone. Welcome to this session number 475. And today I will continue with this problem. Is the last session trying to solve this, and I think that it's possible that I figure out how solve. I was doing this exercise in my whiteboard, and I think that I discovered how solve this problem. But well, again, as a summary for the news, as a summary of this problem, the problem is this: the most profitable part in the tree. And essentially is that you have a tree where you have a tree that is not a binary tree, and you have two players. The first player is Alice. That Alice all the time or always start in the node 0, that is the root, and Bob, that can start in a specific node. In this case, for example, Bob start in the nodes 4. Now the first rule, or the first rule in this game is that both players move at the same time and the same speed. Means that, for example, where Bob move one node, Alice move one node. Now the next point to consider is that where Bob, for example, if Bob is in the node 4 and Alice is in the node 0, like this, 0, and well, in this case, Bob is in the node 3, where Bob is here and move to the next, for example, Bob move to this. In this case, Bob pay for this node. For example, in this case is less 4, and is the first move that Bob means that Bob pay for this, yeah. And where Alice cross for this node, basically the value is 0 because again no Bob pay for it. Basically, where it's negative, you need reduce, and when where it's positive is add or increase, yeah. And another rule is that where Bob and Alice reach the same node at the same time, like this, for example, Alice, the idea is that reach the leaves and calculate what is the final amount. And for Bob, it's only try to reach the short path from to reach the node, yeah. In this case, in other words, Bob move upward, and Alice upward is upward. Sorry. Upward. Bob is moving upward, and Alice is moved downward. Yeah. And where both reach the same node at the same time. For example, Alice moved here in one move, and Bob moved to this node in one move or one step. Both have the same number of steps, or the number of moves, means that is divided. For example, in this case is 4 divided between 2, and every participant or every player win their half of the award, yeah, the award. Or in the case that is negative, is divided between 2. For example, in this case less 4. Do you mean that here is less 4? Is divided between 2, and every player pay for it, yeah, or reduce their current amount less 2, yeah. This is the idea. Now, what is the problem with this? The problem is that we have this kind of tree, yeah, that in this case is 0 is connect with the 2, the 0 is connect with 5, the 1 is connect with 3, the 1 is connect with 5. Okay, means that here I have 1, and this is connected with 3. Yeah, 1 to 3, 1 to 5, and 2 to 4. What is the problem with this? The problem is that the current solution is like this. Yeah. if I add the value of the 0 with the 5, with the 1, with the 3, that every value represents basically here 0, 1, 2, 3, 4, 5. If I apply the add operation over this, 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 and this, the result is more than 20,000. No, in this case is 6, sorry. But for this case, the result is 20,000. What is here? Yeah, 20,328. Yeah, and this is the way. Now, how can I do this? Because on the final here in the description mentioned that where Alice reached the leaf means that you can calculate the final amount. But and what is the leaf? In this case, you can consider it that maybe where the current node don't have any children, it's a leaf. Okay, it's valid this throw or toe, sorry. But the problem is this. For example, this don't have any children. Yeah, but the current answer is this. How can I distinguish between this between this and this? In this case, for example, the 4 and the 3 are real leaves, but the 5 no. How can I do this? Well, again, practicing with the whiteboard, I think that I discovered the solution of this problem. The first that is try to don't think in this as a tree, because it's more like a graph problem that tree problem. Oh, well, it's a combine between both. And okay, now my idea with this problem is that mapping this, but as a graph, and try to have, well, not try to have, is have the indirect graph. For example, the original is in black, and now this is the modification. Add the both directions. And now again, in this moment, how can I know what is the leaves? Okay, in this case, the leaves is exactly the nodes that don't contain children's. Now, maybe do you think what is the difference with this with the previous? In this case, the previous, these don't have children's, these don't have children's, and these don't have children's. Yeah, but in this case, modifying this and convert this as a indirect graph. Basically, here appear the real, for example, these don't have children's, yeah? Oh, no. These contain one children's, that is this direct, yeah? And this is the same. Now, how can I discard in these values? Well, I think that I can use this validation where the current value don't contain any children that previously was visited. Okay, let me think again. Where the current value, well, all the nodes contain at least one element, but where the current node, the number of nodes is doesn't matter, but will have at least one element that hasn't been processed before. Yeah, in this case, for example, when you are here, I will use this color. Okay, now, for example, the first obviously is make the bob. In this case, for example, is the first move. Basically, this value disappear. Yeah. Now the next is in one step. In this case, one step, into step reach this, and in 3 steps reach this. Where where Alice have a greater element, where the number of a step of Alice is greater than the number of step that Bob, Alice pay or win. Yeah, depend. Win. In the other case, Bob pay or win this price. Yeah, but in this case, for example, this disappear because it's 1. Oh, well, disappear because in any moment I remove this element. Now, in this case it's 2, in this case it's 3, and it's enough. It's not necessary to calculate the amounts. No. It's only enough tracking these steps. Now, what happened with Alice? Okay, with Alice, I have another color. I think that, no. Yeah, this is Alice. Yeah. Now Alice is here and the number of steps is 1. Okay, I will do first at this step. Okay, now is 1. In this moment, I need to have one hash set where I need to add the current nodes or the nodes that has been processed before. In this case, okay, I calculate this. In this case, Alice. This is a positive. It's mean where Alice have less steps than Bob. In this case, is this, except the 0, obviously. This case is Alice is not that Bob. Yeah, means that I need to add this value. Okay, I will mark this. Plus is 0 plus this plus. Now, if I move in this direction, okay. Now, where I move this, basically have the same. It's equal, means that the current value of 2, 0, 1, 2, this is divided between 2, and it's only add or reduce, depend if it's negative, positive. This number, in this case, is enough only add all the time, because if you add one negative number, basically is a reduced number, is reduce the amount. Now for this is the half of the 2. The 2 is this. The half is like this. Now the next is here. 1, 2, 3. In this case, this is greater than this. Where the number of Alice is greater than Bob. Ignore. Yeah. Basically is ignore at the value and only stop. And in this moment, for example, I forget completely. For Bob, I don't do anything, but for Alice, every time that I process, for example, in this case is a 0, is add here. Yeah. And now is ask. Okay, let me come back. I am here. The first move is add this in the hash set. Yeah. Because should be unique. Now the next that is I am here is 1. I have this amount, whatever. This amount. Got it. Now what is the next? The next is check what is the children's of the this. In this case, do you remember? It's a indirect grab. In this case is 0. The child is 2 and 5. Okay. I take this 2 and 5. Now the next that is the 2 is here. The number step is 2. Okay, now you remember I need to add this value here and apply the operation. In this case is the half, because both reach this node in 2 steps, and it's done. Now move to the next. The next is 5. No, I think that I need to continue with this. Now I am here. Yeah, now move to the next. The next is the 3, 1, 2, 3, and I add the value. In this case is 4, and now in this case Alice is greater than that Bob. Means that is ignore this value, the 4, because basically Bob paid for it or get the award for cross first in this node is 0. And in this case, for example, okay, give me the children's of Bob. It's only 1. Yeah, because for example, the 0 contains 2 children, 2 and 5. The 2 contains the children of 0, contains the children of 4. That's it. And now the 4 contains only 1 children. In this case is the 2. Yeah, it's connected with the 2. Now I think that it's enough only where you have only one children. And the children hasn't been checked before. Because for example, currently I am here. Now, how can I know that is a leaf where all the nodes contain at least 1 children? In this case is for this, because the only children is the 2. This is the first validation. The number of nodes it's equal 1, and this node isn't in hash set. Yeah, for example, in this case the 4 contains 1 children. Okay, this validation is true. Now the next, that this node is not in the hash set, in this case up here. No, in this case this node is in the hash set. In this case is true. Yeah, because it's here. Basically, with this question, with this condition, I am asking, the current node contains children that is not the parent. Yeah, this is the question, the real question. In this case, I am saying no. Okay, now I have the total. In this case, the total is basically this, that the result is, I think that is this or similar like this. Okay, it's not the right answer. Okay, now I complete this, come back to this, come back to this, and now what happened with this? What happened with this? Now, following the stack trace in this, this is done. Move to the next. In this case, the children are 2 and 5. This come back to this. Now the next stack is the 5. Okay. Now here I will use the. This is for Alice. It's equal 0 because all this time is starting 0. Now the current value is this 5018 plus. Now, for example, now it's in this side here. Now the 0 contains children's, the 0. I am here. Yeah. Now the 5 contains and I need to add this 5 to the process nodes. Now 5 contains children's, yes, or because contains 1 reference to the 0 and 1 reference to the 1. Contains 2. Yeah, got it. I take this and I ask, okay, the 0 has been processed before. Yeah, it's ignored. Okay, basically this is ignored. Now what is the next? Then the next is 1. 1 has been processed before. No. Okay, now I am here, but I have 3 steps here, and again I add the I am here in this moment. Yeah, the first is add this value here. and ask what is the children's of 1 1. In this case, the children's of 1 is 5 and 3. 5 and 3. Got it. Now is to start with the first children. 5 has been processed before. Yeah, okay, it's ignored. Now the next that is the 3. The 3 has been processed before. No, okay, move to the next. And obviously all the time I need to pass the current amount. Yeah. Now here is the 3. Yeah. And the first is again add here, and now ask what is the children's of the 3. In this case only have 1, that is the 1. And again now the number of nodes is 1. Yeah. Node that is 1 is in the hash set. Yeah, is here. Okay, this is another leaf and this is the total. Yeah. And with this I think that we should solve this problem. Now for this I think that where I do this mapping, it's important have a hash set. It's only a single hash map. The first is the key, that is the node, the value of node, and the second is the value in the map is a hash set where is a hash set that contains all the children's. Yeah, and that's it, I think. Okay, I will remove all this array. Yeah, I will reset completely and start again. Okay. Now the first is a hash map. Yeah. Now this hash map is integer and is a hash set of the integer map, and the other is a hash set that integer sin, and the other is sorry, the other is max. Yeah, and I initialize here map it's equal new hash map, blah, 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 whatever. Now the next that is a sin is a hash set, and the last is max is equal 0. Now the next is make this graph, and the way to do is with this h it's equal h. Now here in essential is that if it's two questions here, the two conditionals, h in the position 0 map dot contains key, but where it's negative, basically where doesn't exist this register, create. Yeah, and in this case is map dot put this, and is new hash set, and that's it. And it's the same with the index 1, because you remember it's a undirect graph. I am transform this as a undirect graph. And now the next is very simple. It's only map.get the h in the index 0 dot add. No, it's not add. Hash set operations. Is append or add? Add. Add, in this case is h in the position 1. Yeah, and now the next stat is a positive in the position 0. It's done. Now the first is path. Yeah, I need to transversal the play with both first. Yeah, in this case, is start here, move to this, and move to this. This is simple because on the final, I don't need to. No, it's not simple because if I have this on the graph, I don't know what is the parent. Because, for example, I have two elements, the 1 and the 4. What is the real parent? Because I can follow in this direction, but it's not right. The right direction is for this. Okay. Mm-hmm. Interesting. Mm. Ah, okay. Now, if I have Bob that is in the node 3, when I ask about the for reach the 1, because contain two children's 1 and 4. Now I need to decide for which. Mm, I think that I can create one direct grab, but I think that is not the idea. Because Bob is here. If I ask about his parent, doesn't appear because I only have this graph, and this graph mapping the children's and his uh, parents. No, the children's and mm, I don't like the idea to create another graph only for this. I am trying to think how solve this without creating a new graph. Mm, because the graph contains the parent children's. The problem with this is that, for example, the parent, if I search the tree in the children's, appearing to in two nodes, the 1 and the 4. In this case, could be appearing more. Uh, mm, no, I think that yeah, it's necessary. Not with a hash map with integer and hash set. It's only enough with map with two integers. But I think that yeah, okay, I will solve in this way, and next two I will come back pop map equal this, and this is a simple integer, and it's above map. Yeah, and in this case, or original map, or put H in the position 0. The 0 with the 1. And now for both, I only need to check, okay, the 3 is parent. For example, here is 0 and 1. No, this is a positive. In this case, for example, if I search the 3, I know his parent, that is the 1. Okay, and now for this, in essential is that where Bob reached the node 0 in this moment, you need to stop. I think that with a while is enough. And now integer Bob. I am still using Bob. In this case is Bob. Meanwhile, Bob, it's different. That's 0. And now in this moment, I am here. Bob, it's equal to 3. Yeah, Bob, it's equal to 3. Now the next that is integer Bob steps. It's equal 1. Why 1? Because if I use 0, if I use 0 for define, okay, this is the first, this is the second, I don't have any way to difference between the nodes. Well, in this case, it's only 1. The first node from Bob and the nodes like this, where Bob never crossed for it. Yeah, for this reason, I am using the 1 as a value. Now here is sure. Here I need to identify I need one array for the terminate. What is the current node? It's only for both. The current node, the number of steps, the number of steps, and that's it. The number of steps, the node, the number of steps. Yeah, I think that I can use one array, another map. Both and essential have the same time complexity. I think that one map. Integer, the first is with the node and the number of steps. Above steps map. Yeah. And I will initialize here. Yeah, and here is Bob steps map put. In this case is the current node, that is Bob. It's Bob, no Bobo. And in this case is Bob steps. Now, obviously, this increased in 1. And the next is search the parent of the Bob. In this case, above, it's equal map Bob map get Bob. In this case, for example, Bob is 3, and I am getting his parent, that is 1. Yeah, this return 1, and now I am here with the number of steps in 2. Okay, now I put this value here, Bob steps, and is complete, and Bob, it's equal, you know what, or default The default is 1, and here is what is different to this one. Do it this. Why? Because I need to reach this. Because, for example, do you imagine that only the, like this, I have this, right? Alice and Bob. And both reach the same node at the same time. This with this and this with this. I need to consider that 1, 2, 1, 2. I need to consider this operation. For this reason, it's necessary to reach the 0. No, stop in this moment, complete the task, and do it. Now, it's enough with this. And yeah, in this moment, I forget completely of Bob because I know how many steps have in every node where Bob crossed. Okay, now the next step is start with Alice and apply this operation. Okay, I will use this comment where Alice steps it's minor that Bob is still writing Bob. Okay, where Alice it's minor that Bob use the amount plus the amount. It doesn't matter if it's negative or positive. Where Alice is greater than Bob means that ignore, and where both are equal amount between two, and in this case is ignore. Okay, this is the rules. Now the next step is again obviously start with Alice. In this case, I need to do one DPS, and this DPS should receive the node, the steps, and the amount. In this case, the node is 0, the steps is 1. Do you remember that I need to start with 1? And the amount is 0. And in this case, return max. Now, I need to create here a private function that is a void DPS, yeah, that in this case receive the first integer node, integer steps, integer amount. It doesn't matter. We don't feel worried for the amount, for the double values, because in the final all the values are even. What one point mentioned this that are even. These values obviously, no the nodes this, because here these nodes are between 0 and n less 1. Yeah, 0, 1, 2, 3, and 4 means that n is 5. Now okay, now I have this private void, blah, blah, blah. Okay, the first is valid if okay, no, the first is add this value to the scene. This is the first. Now here, now is increase the number of steps. Okay, now I need to check if Bob grows in for this node and update the current amount. Amount plus equal, and Again, I need to check if Bob cross for it for this. Okay, and the way to determine this is with a simple question. If Bob map, for this reason is important, this map, no, is Bob step maps. Contains contains key and node in this case, where is contained means that has been Bob has been before here in this node. What happened is I need a divide validate these rules. Yeah, even I think that I will paste here. And now I will remove from here. Now here is the first. I am sure that Bob is has been before here. Yeah. Now the first is that how many steps have Bob or had see how many steps Bob had in this node. In this case, for example, this is the value, and for Alice is only steps. Okay, Alice start with 1 here. 1 and increasing 2. Now teachers. No, this is wrong. This is undefined. In this case is 1. And I ask 1. And before to send, I increase. This is 2. Now here, this is 3. And in this moment, I ask 3. Yeah, it's in this way. Now, Alice is minor. Okay. Is steps are minor. Alice, it's minor the 12 steps. I only amount it's equal amount plus I need these values. This. And I need to declare in this way here. This is equal this. And now here is amount R. Now it's array amount. Now here it's array amount. And here is amount plus array amount in the position node. Means that Alice paid or win all the amount. Now else if where both are equal, I need to divide between 2. Yeah, basically it's this again, but with the difference is that this is divided between 2. Yeah, and I apply this, and yeah, I use it this way because I'm not sure what is the behavior if, for example, I use amount plus equal this operation to divide and with the negative number. Well, I'm not sure. For the reason I use this way. Now, and for the last, well, it's so simple, ignore. It doesn't matter. Now, what happened where both hasn't been before here, means that in any moment cross for it. Basically, it's only this. Yeah, that's it. Now I increase the number of steps, and it's time to transversal the children's of the current node. In this case, the 0, the children's are 1. Okay, in this case is integer and double point map get node. All the time, all the nodes contain at least one element. This is sure, is a warranty. Now is ask if scene contains n, but in negative, means that if this process, this is the first time that I am visit this node, um, in this case, by DFS with the values, node steps and that is now steps in the current amount, that is this. Now, how can I know that that I reach the leaf? Well, in this case, I think that it's only enough creating counter it's equal 0 and increase this in 1 every time. And here ask if counter it's equal 0, means that in any moment execute this, means that it's a leaf where the counter is no, means that is a leaf. Yeah, and in this moment it's necessary calculate the final amount. Max it's equal math.max between max and amount. And that's it. Okay, this works. This doesn't work. Here, Alice and Bob. Bob pay for it and Alice pay for it. When I move to this and I move to this, basically is 0 and 0. I am returning 0. Yeah, because Alice is here. Bob transversal, and this is 1, this is 2 done. Now, in this case, this is 0, means that Alice is minor that Bob when this negative number is 0 plus less 7,218. Now move to the next. In this case is 1, 2. It's ignore, don't do anything. Now it's here. And I need to check the children's of this is 0, but 0 has been processed before. What? I'm not sure what is happening here. Why return 0? Only for be sure, I will change this by let's this. If appear this value means that I am return. Sure. Yeah, I remember. This can't be a 0 because, for example, where appear only negative numbers, in this case, the 0 is greater than these negative numbers. Means that I need use the. I think that here appear the n. The n is this value, and is this. I think that is 101, 100,001, like this, but negative. No. No, yeah, negative. Now I will submit. Come on. What is the error? Output 8,838. 02 06 13 15 25 46. Very, very quickly, I will make this 3. Now, I was sure that the algorithm was right, but well, something is happening here. The 0 connect with 2, connect with 6. Now the 1 with 3, 1 with 5, 2 with 5, 1 with 5. I think that I can, and is connect with the 3, 1 with 3, 1 with 5, 2 with 5, 4 to 6. Now what is happening? In this case, Bob is here. Means that n is an direct grab like this. And now Bob is here. That is 1. Now move to this in 2 times. And basically the 6 0 1 2 3 4 5 6 things disappear because it's 0. And now where Alice go to this here, I think that the answer is for this, I'm sure, but in this case is 1, means that this is for Alice and this is for Bob. Yeah, in 2 elements. Yeah, is for this, because what is the sum between 0 6 and 4? Let me check. If I use the 0, that is 38 plus the half of the 6, because Alice and Bob reach this position in 1 step. No, is Alice is 2 steps. No, 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 I was wrong. No, no, no. In this case, this is 1, this is 2. And if I follow this path, 1, okay, this is for Alice. The second is for Bob. And this is for Alice. Well, basically all of them are for Alice. In this case is 2. And this is 3. Yeah. And I need to sum this 0 plus 6 plus 4 completely. Yeah. This is one path. Another path is a 0 plus 2 plus 5 plus 1 plus 3. Now, if I add these values, let me check what is the result. For the first 0, 0 plus 6 plus 4, with these values is the 0 contains plus 6. What is the 6? The 6 is not valid because has been Bob paid for it. And is plus 4. The 4 is less 1366. And the result of the dispatch no. Plus 6 that is empty plus 4 that is less 1366. Okay. The result of this is this. For this path, this is the result. Yeah. And now for following this path, the result is okay. The 0 is 8838. Now the next step is the 2 less. And now the next step is the 5. Now the next step is the 1 that is negative. And the last is the 3 that is positive. The result is 3008. What? Is 0? Well, is this plus this. 88 plus now the next is the 5. The 5 is now the next that is the one that is negative. 6396. And the last is the 3 that is positive. I am having a incorrect answer. Is this 020613 152546? This is the result. I am returning this. Oh no, the answer is this 7,472. And I am returning this because I'm sure that I am following another path. Maybe this. No, it's not this. It's for this here. Now why I am reducing? Okay, let me make one calculus. less the half of this. Sorry, the half of this value plus the half is 1 7472. Okay, yeah, this error, I think that maybe because I am counting the half of the this. In this case, the current answer, the right answer following this path, 0, 6 to 4. This is the answer. Now, in this case is 0. Now, this is 1 and 0. In this case, Alice is minor than Bob. No, Alice is greater than Bob. Alice is minor than Bob. Alice is equal to Bob. No, but even in this case, I am... What is happening? Okay, in this case, I am... Bob is less 1. Done. The steps is 3. 1, 2, and well, increase. Yeah, whatever. Now, I start with this. The first time should be 0. This, and have 2 childrens. In this case, Bob is contained here. Yeah. But Alice is minor, means that I need to add all the... What? Yeah, sure. Alice take all the amount of the current node. In this case, the amount is negative. The node is 2. It's in this side. Sorry, I forget to stop. Now, for the 2, it doesn't matter. The amount is this number. It's okay. Now the next is the 5. Now the 5 is contained. No. Okay, I add. Yeah, because basically for this, Bob never cross. Now is the 4. Now 4. Why the 4? Why appear? No. It's the step. No, it's the node 1 that is this. I am very close to complete this transversal. Now this is the last because it's the 3 and the 3 don't contain any element. In this case, I calculate here the value. The content should be 0. Perfect. Now I have this amount in this. Got it. Now okay, now I am in the node 6 here to this. The number of steps is 2, is right, because this is 1 and this is 2. Bob contains this, yeah, with the value of 1, means that steps is not minor than Bob, because steps is 2 and Bob contains 1. Don't do anything, it's right. The amount is this. Wait a minute. Is 0 plus 6? Node 6. I'm here. Where I move to the next, I keep the first value that is the 0 because this basically is ignored because Bob paid for it. Yeah, and it's 0 in this moment. Okay, now I increase the this, whatever. Now the next that is, give me the children's of 6, that in this case is 0 and 4. The 0 has been processed before, means that I don't do anything with this, correct? Now the next that is 4, that is this. And the 4 hasn't been processed before. Is that is 4, the steps increase it, that is 1, 2, 3, and the amount is the this. Well, here appear. Encounter increasing 1. Now, where I go to the this value, no, sorry, this. Now I am in the 4. The steps is 3. In this case, is the else. What? Why both steps contains the key? And the key is the node 4. Why the 4 appear in the path? Why Bob put this 4 in here? Because the node is 4, and I am saying that Bob crossed for this, but it's not true. What's happening here? I think that the error is here. Bob is 4. No, is 6. That is this. Now I am saying that the 6 contains one step increase, and now give me the children's of Bob. In this case, the children, it's only the, sorry, his parent is only the 0. This should have the 0. Bob is for y. Why? I am wrong here. This is the parent. This is the. This is wrong. Because here appear the 4 and is wrong. Bob map. No, it's right because it's his parent of the this. Okay. I got it. Here. No. Here. If this is minor than this, greater. But for example, this is greater than this. The parent should be greater. No, this is wrong. Hmm. Oh, I think that I can use a flag. And where appear both, I need to stop to save these values, or this value specifically. Um, and now here is flag. And here if h in the index 0 appear, it's equal both, flag it's equal this. Meanwhile it's different. Set true in the moment that is false. In any moment, do again this operation. What is happening? Why is still putting the... We have one. Okay, well, I think that it's enough. How many tests? 21 of 31. Yeah, I think that is for something similar, but well, I think that is enough for this transmission. Thanks for following this streaming, and I hope see you in the next. Bye bye.